Welcome everybody to Robot Builders Night Virtual for April 15th, Tax Day. And I hope you all paid your taxes, and we won't worry about taxes anymore because we're going to talk about robots. Only got one person in the queue at the moment, myself. One thing I just on the DPRG news front, just before we get into the queue, in Saturday week, I believe we will have Saturday week we'll have the monthly meeting, and it's going to be an exhibit. Bring a robot, and we'll have the contest courses laid out, and you can try out your robot, play with it, develop it. It's intended to coincide with the Dallas Makerspace open house. Mark, have you heard anything about the DMS open house? And it sort of sounded from when I was there before like it's, a little bit iffy as to whether people are it's really getting organized properly, or has that turned around at all?
It's still fairly quiet, but yeah, that side of the makerspace up by the flex area and printmaking, that'll be busy. The lobby should be busy. Okay. So we should have traffic.
Okay, good. I was thinking if we could borrow one of the DMS laptops and put together maybe a composite video of maybe some recent contests, and that we can just play on a loop on the monitor.
Mm-hmm. Yep.
And so we'll start at the usual time, 10-ish, and we'll have pizza for lunch, and we'll go through sometime in the mid to late afternoon whenever we feel like we've had enough fun and people aren't coming through anymore. Okay. With that, I'm going to switch. Sorry, was there a question? Okay. So I want to share with you guys some pretty cool stuff that I've been doing in terms of can identification based on a LIDAR scan. And so this is all on my little robot mini bot. It's got the spinning LIDAR working away there. And so I'm going to share my desktop and show what's been going on. Entire screen, that one, and let's see. Yes, I think you all are seeing the terminal, and looks like it.
Yep.
Okay, so I'm going to start the robot bring up code, and so that starts Wi-Fi and starts a sequence of ROS nodes, a number of ROS nodes that deal with talking to the robot, and then we'll start the 6CAN navigation software, which doesn't actually navigate around yet, but I'll set the initial pose. So I bring this down, and to the pose estimate, it's about there. Maybe not quite. Okay, close enough, I think. Okay, so first off, what you're seeing here is the LIDAR scan in white jiggling around, and it is looking at this my arena. So I've got a board along one side underneath the workbench and a board along the other side underneath the workbench, and then the back wall is what you're seeing here. And you're seeing two U-shaped things here. Do you all see this? A yellow sort of like U-shaped thing, two of them with a kind of red and purple thing in the middle of them?
Yes. Yes.
Okay. So those are the two cans. Well, you can see one of them is just down there in front of the robot and a little off to one side. There's another one over there and another one over there. It's only picking up the two of them because I've got a range limit of 1 meter for can detection, and you can actually see this one on the top left is jumping in and out a little bit. So and you can actually see the shadow, like up here is the shadow the LIDAR shadow cast by the can, where the bits of the wall are missing because the can is obstructing the LIDAR beam. And so this is what I'm going to show. It's really the can detection in the LIDAR. But first of all, so that is what I'm showing here. And in the background, we have the map. So if I turn off the controller visibility, nope.
What does the length of the green and red bars indicate? Like, what is the larger object that the arrow's going up to a larger one and it has a longer green and red?
Yeah.
What does that indicate?
Really good question, Daryl. So first of all, the red and green axes coming out of the robot are the robot origin and the wheel origins. But then this line going from the robot base to this this axis up here is the transform from the robot base to the ODOM frame, and then this arrow down here is the transform from the ODOM frame to the map frame. So the map axis is fixed at 0, 0, and the ODOM frame gets moved around by the map frame to ODOM frame mapping in order to keep the LIDAR lined up with the map and the walls that are shown on the map. That's a short answer. There's a longer answer, but if you go back to the last monthly meeting, I did a talk on ROS navigation and liner robot, and I explained more about what the frames mean there. But is that a sufficient explanation for now?
Yeah, except for the can obstacles have little frames too. But they're obviously much smaller, shorter. Does that denote like that the height of the object or anything in any way, or what is?
So that's a really good question too. That's actually so the can canfinder software is running, and that is actually a pose array. So the canfinder software is outputting an array of poses of all the cans that it finds. And so here I set it's listening to the topic can positions, which is publishing a pose array, and which is the array of found the poses of the found cans. And I set the axis length and radius real short, just so it's a kind of a blob that marks the center point of the can.
Okay, thanks.
Great questions, Daryl. So now I'm going to kick off. Okay, so we got to move a robot here. So I'm going to move, launch some action servers that are based on what I developed been developing for the last year or so, or a couple of years, and used in RoboColumbus. And then kick off to run scripted bot driver, find can, find scripted bot driver, scripted mover, seek to can. Okay, so this is going to issue a command that will cause the robot to seek to the can, and so I'm going to kind of try and stand out of the way so you can see the video, but also bring Avi's up into the foreground. But just to say a word about what's going on here, the canfinder software is publishing the closest can position. So let's see. Can you guys read this? I don't know if it's too small. Yeah, I guess you can. Okay, there should be a. Why don't I have closest can? Let's see. Last topic list. Why don't I have closest can? I don't understand that. This may not work. Well, I'll give it a bash, but I'm not all that hopeful. The hope is that it will seek to this can and stop when it gets there. But I'm not seeing the topic that should be being published that would cause that to happen. So let's. There it goes. And I can see it kind of, well, it drove right up and stopped when it found the can. So I don't know why I'm not seeing the topic, but the canfinder is publishing a topic that contains the bearing and range to the can. And so this seek to can action drives turning to change the bearing to reduce the bearing as close to zero as it can get it. So like if the position of the can sort of moves around a bit, it'll like as the LIDAR scan gets closer, it'll seek in towards the center of the can, and then it'll stop when it gets to within, when the can range becomes less than 10 centimeters, which is the distance from the LIDAR to the pretty much the middle of the jaws. So that was the robot moving demo. So I guess I get a gold star for the robot, for moving the robot.
Give yourself a gold star.
Give myself a gold star. So let's see. Just a word about the logic that's happening here. And go to
Hey, Paul, can you make that window full screen?
yeah. And I'm currently on Rev 5 branch. And so one of the things it's doing is, so it finds cans in a LIDAR scan by finding sequences of LIDAR reflections that are close to one another, but each end is distant from neighboring points outside the sequence. So such sequences could be reflections from cans, but they could also be reflections from other things like the walls. So they're further qualified by sequence validation checks. And one of them is this this check on the number of LIDAR points in a sequence whose ends terminate with a big jump in range to whatever's behind the can. So if you take a can radius, and these cans are 6.6 centimeters diameter, and you take its range from the midpoint, then the angle theta of subtended by half the can is tan minus 1 of radius upon range, opposite over adjacent. So then the angle subtended by the whole can is a function of radius. It's 2 times of range. It's 2 times tan minus 1 of radius over range. So here. So and the LD19 LIDAR has 455 LIDAR points covering the 360 degrees. So each point covers about 0.8 degrees. And so it actually uses the range to the midpoint of a sequence, which is actually on the front of the can, but it's close enough to work. And then, so given a sequence with a midpoint at range R, the angle subtended by the can can be calculated, and the number of LIDAR points in an ideal scan reflection calculated. So, so the algorithm checks for the number of scan points in the sequence being consistent with a can that has diameter 3 centimeters to 8 centimeters. And so that's how come you see some things like this curved thing here is my trash bin, and
It's the biggest can of all.
trash can, yeah. Thank you, Ray. And it doesn't get found by the canfinder because it's filtered out, because its number of points don't meet that that criteria based on range. Another validation check is that the shape is convex, which is checked by the end points being further away than the midpoint. So the code for this canfinder is generated entirely with iterate, and I'm going to talk next about how to get iterate fired up, because Doug wanted me to talk about how to get started with Ada. But one thing you can do that's kind of nice is if you write the instructions to Ada. So Ada is a pair programming tool, and if you write the instructions to it in Markdown, then in GitHub you can just click on the Markdown and get a nicely formatted display of what's in your Markdown instructions to Ada. So and so this format I shamelessly cloned from Bruce Wilson, who gave a talk on how to use Ada a few RBNVs ago, maybe a month or so ago, and he got this, I believe, from Indie Dev Dan, and so anyway, it's got things like it's got example codes for reference for a minimal ROS2 subscriber, publisher, server, transformer, and then the low-level tasks that tell Ada what to do. Okay, let's see. So before I get on to Ada properly, are there any questions that come to mind about the demo of finding cans and in a LIDAR scan?
No, but Paul,
Yeah.
could you put your? I know it's funny. I know you have GitHub, but can you put your repository name where you have the Markdown? Since you're saying that's a step. If I understand you correctly, that's a template. That's otherwise there should be a high-level task, then a low-level task, and it's an example of it, right?
Yes.
Am I following you right?
Yes, you are. You are. Let me put that down there. Okay. There's the URL. So okay, so you can get to the README and the adafindcans.md if you want to use that as a template for how to talk to Ada to get it to generate code. Okay, so having moved a robot, I'm going to move on to how to get started with Ada. So I made a slide here, and I'll post that URL as well. It's public. Okay, so how to get, what's that? How to get going with Ada, and again, just to not to be too repetitive, but the canfinder code was entirely generated by Ada. I had written the code that drives the robot previously, and there was a modification of that. So first of all, you install Ada per this URL, adachats.docs.install, and that will take you to this page. And basically you pip install Ada install, and then you run it, and then you cd to a project, and then you run Ada, and here's some example commands of how to run it, giving it an API key. And so that's how you install. So that's installing Ada. And then you need, I'm using Google Gemini to as the AI that backs Ada. I'm not really quite sure where Ada leaves off and the AI starts. It appears to me that Ada reads commands and context, but then passes it off to the AI, and it supports multiple AI LLMs like Claude, Sonnet, and ChatGPT, and lots of those, quite a few of those, I should say. And that does the heavy lifting. The LLM does the heavy lifting of generating the code. So in a way, it's as if you put into ChatGPT, design me a canfinder and all of the instructions that I'm about to show you, except that what Ada layers on top of that is the ability to directly write your files and check them into Git, and to add references to other files. And I know it does. As I say, I'm not too sure where Ada leaves off and the LLM starts, but anyway, what you need to do is, if you want to do this for free, get a Google Gemini API key per this URL, which takes you to this page. And I didn't have to give it a credit card or anything. I'm on the free plan, but maybe maybe Google already has my credit card. I don't know, but anyway, I'm on the free plan, and then at least in Linux, you export this variable Gemini API key to be whatever you got back when you click this button and ask for API key. And then they give an example Gemini request, API request that just checks out that the API to Gemini works. So that's about as far as you need to go on getting the API key. Then you need to export the API key in an environment variable. So just like it showed on the page there, export Gemini API key equals whatever it told you. And then make a temp work directory and cd into it. And in that temp work directory, which I'll demo this here in a second, you initialize a Git repo in the work directory with the command git init. And what that Ada wants to work in a Git repo, and so whenever it generates some code, it checks it in with as a check-in, and it puts reasonable comments against it, and then you can undo the check. You can tell it to undo that check-in if you don't like what it did. But that's how you get started, is initializing Git repo. Then you launch Ada, and here's the command I use. Ada -- model is the Gemini version here. So this is the version that you can use for free. And then the -- architect flag tells it to do two passes across whatever you tell it. The first pass is a high level. It calls itself an architect. I think that's a bit of an overstatement. I don't think it's really doing architecture. It's really generating code, but whatever. And then it passes that off to something it calls an engineer and says, hey, engineer, implement this. And then engineer goes through and finds diffs and finds where in existing code, if the code does already exist, where to put that the code that the architect gave it. And at the end of that, you have some either brand new code or some modified code. And then you ask Ada to do something after launching it. I actually, when I'm generating this canfinder code, on the command line, I give it the Ada find cans.md. And so then it sucks that in right away as context. And then I tell it, perform the low-level tasks and generate the canfinder class as described in the Ada canfinder.md file. And I'll demonstrate that here in a little bit. So let's just go through this this sequence of things and make ourselves a little app. So I'm going to cd to temp, and I'm going to demo making a little app. So we'll make a directory called snake because we're going to make a snake game. Mark's already done this, so should be a good demo. Cd snake, and then we do git init. So this initializes the git repo. So now we're ready to run Ada, and I run Ada through an alias that I call Ada arch, which is just what I showed on the slide. So let's run Ada arch. I don't want to install the latest version. Well, actually, yes, I'll just show you this because this happens most every day. Ada is in active development, and it keeps on almost every day when I bring it up. It wants to give me a new version, so you just say, yeah, install the new one, and then well, you have the next version. Do we want to add Ada star to .git ignore? Yes, because it keeps a log of the chat in .ada .chat blah blah blah. Do I want to see what's new in this version? No. Okay, so now we've got the architect prompt. We can ask the architect to do something like create a snake game in HTML. And it's kind of interesting and fun to see it do its thing. It goes away and thinks for a while. And then, okay, now it's talking to the editor engineer, saying we need to create a simple snake game using HTML, CSS, and JavaScript. Here are the instructions. Create this index.html file, add the basic structure, include this stuff, and then here's the stuff that it's adding, and then it's creating a CSS, telling the editor engineer to create a CSS file and a JavaScript file containing all this stuff. And so that it tells you that provides a functional starting point. Okay, so then the engine.
Hey, wait, Paul.
Yep.
Can you slide your terminal before the code? You said Ada said this. Is this from your file?
Nope.
Is this?
This is not from anything. This is just from the text that I input to it.
Okay, so all you had to say was create a snake game, and then it went off from there.
Yeah, it's, I mean,
everybody, that's a simple task. I understand, but
yeah,
I'm,
but you're right. That's all I had to say. So it's a powerful demonstration that it understands what a snake game is and
Yeah.
understands HTML, understands, and we'll play the game here in a tick.
Okay.
But yeah, and so it's here. It's
so this part right here where it said, it gave itself some instructions.
yeah, it's actually talking to the editor engineer.
Yeah.
So there's two of them. You get two engineers for the price of one. You get the architect and you get the engineer. So this is the architect talking to the engineer, saying, "Here are the instructions," and it gives these code segments.
Okay.
And then the engineer will actually write the code or modify code if it already exists.
Yeah.
That answer your question, Doug?
Yes.
Okay, so we go down to the end of the code. So now it tells you it used these tokens, this number of tokens. Now here's the editor engineer replying. Okay, I understand. You want to create 3 new files and names them. Here are the search replace blocks to create these files. So if you're modifying code, you'll find search for this pattern and then replace it with this other pattern. But since we're creating from scratch here, there's no replace section. And that's it. Do we want to create a new file? Yes, we do. Yes, we want to create style.css and script.js. Okay, and that's it. So now I'm going to leave Ada open and cd to that p/snake. And there's the index.html script and style.css. And we can look at the index.html and that's just, yeah, it's some HTML. So let's fire up a browser and get this and try it out.
Oh yeah, you got a motor. Good fit, sir.
Okay. I had previously done the snake one, so fortunately the browser remembered that URL. Okay, so this will open that local index.html file in the browser window. And there's the simple snake game. And let's see, so we try. Okay, you get the idea. This is game over. Got a score of 30. All right. So looking good so far. How about we modify it by adding a start button? So we'll go back to architect and say, ask it to modify the snake game by adding a start button. And let's make it run slower because it like is running too fast for me. So I mean, hopefully you're seeing that it's like really deeply understanding, and but it gets better yet. So
did you have to include the modify the snake game portion of that, or should it have picked up that context?
Good question. I don't know. Yeah, we want to add these files to the chat. I don't have that much experience with this, Kareem, so I
Sure, no problem.
there's a fair bit of this that I can't understand, that I don't understand. Okay, so let's reload this. I don't see a start button. Did it fail to? Okay, so what you can also do is complain to it.
You're on your own, buddy.
I don't see a start button. And sometimes it'll, so it's telling the editor engineer that the changes that they discussed previously were not applied to the files that were just provided. So this is funny. The architect is kind of blaming the engineer, saying, "Hey, engineer, you didn't do the job right. You didn't update those files." So off we go, and let's try it again. Reload it, and there's a start. Oh, there's a button that it decided to call Start Game. So let's click that.
Good project.
Oh, and it slowed it down too. Look at that. That's more my speed. Okay, you get the idea. Okay, so just to recap, what I've demoed so far is starting Ada, giving instructions in plain English to make a snake app, and that just worked. It's amazing. It really is amazing.
Okay, Paul, I want you to make one small modification. Tell them, have the architect tell them that has to score over 100. He has to have the game score over 100. Otherwise, the game automatically plays and ends at 30. I don't know why.
I'm sorry, Doug. There was something I didn't explain. To kick off the game, I was actually hitting the arrow keys. So I was driving the snake.
Oh, okay. Hey, Paul, get better. 30's a pretty crappy score.
Well, I let it run into the wall because we're not here to play Snake.
Yeah, I got you.
Play Snake. We're here to talk about Ada and
Okay.
and how to make code easily in plain English. All right. So there are a number of commands that are useful. /quit. So this is all of its commands. /architect. We start that up with the command file. /add is where you can add files to the chat, so Ada can edit them or review them in detail. There's a read only is to add files to the chat that are for reference only, or to turn added files into read only. So that lets you distinguish between files that you're willing to have let Ada modify and those that you are not. Those are the most. You can also give git commands. So those are the most. And /undo will undo the latest git commit. So I'm going to quit Ada here and launch git k to have a look at the repo. So you can see that. So git k shows the history, the git history graphically. So its first commit was implement basic snake game with HTML. So it wrote a reasonable comment on the git commit. Then the second commit was implement the start button and move modify game flow. Okay, so that would be the speed. So there you go. Any questions on the snake game before I move on? Okay. So I want to talk now about the philosophy of using Ada and having specifications and vibe coding. So this is the the graphical Git history for the canfinder. I'm up to Rev 5 at the moment. And so it started down here, and you know, there was an old master and a Rev 2, and at some point I made a start over point, which is still where the master branch is. And there I renamed scan analyzer to canfinder. And basically this is where I've started over from scratch, meaning started over from a modified Ada canfinder.md file, but generated the code from a blank file about 6 times so far, and each time for good reasons. As I learned more about the problem, and at one point I discovered I needed to rotate the scan, because if cans are in front of the scan and the LIDAR 0.0 is at the front, then it was hard to span and hard to explain to Ada how to let sequences of cans span across from the end of the scan to the beginning of the next scan. Is one example. Other examples were outputting additional data, like a pose array of found cans and the closest cans, bearing and range, so forth. You know, and so the workflow that I'm using here is to keep the Ada canfinder.md file up to date with the latest specification for the application, and to rerun the code generator from an empty file whenever I want to make major changes. I've made some minor changes, both by asking Ada to make a minor change and by doing it by hand in the code. But for any significant feature addition, I generate the code entirely from scratch again, based on the specification in the Ada canfinder.md file. And I'll show what's in that file here shortly. But this is the opposite of something called vibe coding, which seems to me, from the little I know about it, and I might be off base here, my experience level is very minimal, but vibe coding seems like absolute BS to me. What it really amounts to is give Ada some instructions, or give an AI broadly some instructions on the general kind of thing you want done, then try it out and see what it does. Have a look at the code and see if it makes sense, and then tell the AI to change it in ways that you think it needs to be changed until you get to something that works. That is an absolute non-engineering approach to doing a design of a software module. And it might be adequate when you're doing something small, a standalone toy like a snake game, but it's not going to be adequate when you're interfacing with a complex software environment like ROS, with other nodes that are driving the robot and planning paths and navigating and all kinds of stuff. So the approach that I'm using currently is to specify things in a fairly high degree of detail. Now, I suspect I can probably back off the level of detail that I'm doing. I'm inexperienced, as I say, with this, and starting conservatively and getting excellent, really excellent results, which I'll share with you here shortly. So is there, yeah, so every time I start over, I make a new branch from the start over point, and here's Rev 4 that was, so here you can see where feet is where Ada added a feature. So I told it interactively to add a TF2 buffer and can pose transformer. Then I manually made some fixes. And then I told it to fix up some build files. Then I told Ada to remove an unused variable that was getting a warning when I compiled. And then this would be my comment because it's not preceded by something like feat or build or refactor. I did some cleanup. Then here's some more features. So you can see I did quite a number of interactions with Ada on this Rev 4 to get it to get the software working like I wanted. But each time as I gave it some instructions, I also put those instructions into the Ada find cans.md file, so that next time I wanted to start over from scratch, I had a complete record of how to get to the software in the last state that I was happy with. And so then Rev 5 is when I started from the start over point, and at that point I had my my find cans Ada find cans.md file, just fed it to it. It checked in this implement can detection and pose estimation. I told it to fix something about how it calculated poses, and then I checked in the README and the Ada find cans.md, and I so yeah. So anyway, that's the workflow that I'm using. So any questions about like the workflow and the use of Git and the use of specifications to tell Ada how to write the software, or discussion or anything? Okay. So now I'm going to go to bring in code. Let's see, is this readable, legible? Maybe need to make it a bit bigger. Okay, so one of the nice things about writing the instructions to Ada in Markdown is you can then render it on a web page. In Linux, there's a tool called grep that will send a Markdown file off to your browser window. So I've got there's my first level heading. There's a couple of second level headings. You can use this tick bash to get things formatted in Markdown. Tick CPP. So here's where I'm giving it reference code that I just pulled out of the ROS2 tutorials for a minimal ROS2 subscriber, to show it how to do a ROS2 subscriber. I'm not sure if it already knows. It may well, but better. I'm acting conservatively here. Okay, so then skip past all the reference code. Okay, so here are the low-level tasks ordered from start to finish. I tell it to step 1, create a canfinder class. Then I encode, and Bruce showed this trick of encoding the instructions in a tick Ada, so that kind of makes them indented in the in the rendered markdown. So now I'll go to, this is the rendered markdown that we were just looking at. So here's the heading 1, here's the high-level objective, there's heading 2, mid-level implementation notes. And this is just easier to read because, you know, the headings are all different sizes and just makes it nice to be able to understand what you're saying. So there's the reference code. Okay, so here are low-level tasks that we just looked at in markdown format. Numbered, create a canfinder class, create this file, define the class canfinder, mirror the provided minimal subscriber code to create class canfinder, subscribe to this topic with message type such and such, and add the private callback method called scanCB, which is defined below. So you can see I'm using, going into significant, I'm giving it design details here about how I want this thing built. Here's the scan callback method definition, and one of the key methods is this call. Oh, we probably need to make that bigger. Call a private method called findCans, which we'll take a quick look at here in a little bit, which is defined below. Pass a reference to rotate scan reference to these new messages. Okay, so then further down we find the findCans method definition with a description of what it does. Identify sequences of can ranges that represent soda cans by searching the list of ranges in the input message and applying validation rules. Output these sequences. So these are all instructions to Aider, along with the array of their positions. Note that in the LIDAR frame, X faces forwards and Y to the left. So then I tell it some stuff. I give it the validation rules here. Okay, so you can see this is a fairly complicated algorithm, and I'm specifying it fairly precisely. Oh, and I also showed this file rendered on GitHub, I believe. AiderFindCans.md, and there's the same thing on GitHub. So you can look at GitHub and as well to see it. So now I want to show a couple of things that I think are just mind-blowing that it did. It writes one of the instructions that I gave it.
Hey, Paul,
Yeah.
real quick. You're using VS Code.
Yes.
Do a right click on iterfindcans.md. Yeah, and click on preview. A little bit further down. Whoop, you went right past it. Open preview. There it is.
Thank you. I forgot about that.
Yeah.
Yes. Very nice. So somewhere up here, I told it to comment the code. Implementation notes. Be sure to follow the low-level tasks in order and in detail. Use the current Git branch. It'll be a C++ node. Add doc strings and comment the code. And it did all of those things. And in particular, I'm going to jump down. So first of all, I'm just going to show a couple of segments at the beginning of the class. So here's the class, and it created, here's where it creates a subscriber, and it puts in all these comments saying what it's done. And then here's the scan callback message. It puts in a doc string comment to say what it does. Okay, so now I'm going to jump down to the find cans method and show some things in there that just blow my mind. Canfinder. Here we go. Find can. So here's the find cans method, and we'll go back to find cans in the markdown and look at some correspondence between them. So I told it to overwrite each range value in the output message with a nan that's not a number, except for those that are part of a valid sequence that represents a found can. And so it did some things I didn't even know about in C++. Like here, a quiet nan, it defined a quiet nan and assigned it to this nan val that it's going to copy in where appropriate. I didn't even know there was such a thing as a quiet nan in C++, but it's a nan that gets propagated through math, through equations, and 5 times a nan is a nan. Then it did an STD fill. I don't know these STD, or they used to be called STL in the olden days of C++. I didn't even know about how to use fill, or that didn't even really remember that it existed. But it filled this can-scan.ranges array from the beginning to the end with this nan val, that quiet nan. And it can write in Python too, or other languages.
Have you tried it on other things besides cans to see if it does a good job at coming up with detecting other types of objects? Like that are vastly different from cans?
No, this is really the only real, solid example I've done. It's my first real example. So I'm sharing with you guys hot off the press, but my experience level is limited.
Yeah, I think
in point cloud analysis. Sorry.
Yeah, Daryl, this is not. I don't think this is a point cloud. This is just it's a line. Okay,
but it's a 2D point cloud.
Okay, 2D point.
Yeah, and point cloud, so which is a simple case, but cylinder detection is one of the well-known problem spaces in point cloud analysis. It comes up an awful lot. Usually, you think about it in terms of 3D, but it's like there's a lot of examples of how to do that out there. So if you look at the PCL library, there's probably like they have a cylinder model that's sort of part of the basic functionality, and you just need to configure it appropriately. So so there's a lot of literature out there, and that's when the AIs, the LLMs are at their best.
Yeah,
is when there's a lot of examples to pull from.
Oh, okay.
Thank you.
More complicated object detection is an entirely different kind of thing, right? So it's planar detection is number one, right? So you can detect the floor and get rid of it if you have like a 3D point cloud, and cylinders are pretty common as well.
Thanks, Kareem.
Sure.
So some of the things that it did down here that really I was like, wow, it would have been way harder for me to generate, is it did some stuff with these STL libraries, the STD things that I didn't know how to use, like sort. Let's see, finding the ranges here. Okay, if the valid sequences are not empty, then sort. And it looks like it created a lambda here to and fed it in as the method to use for comparing two sequences to sort them by range to the midpoint. And this kind of corresponds to where I asked it to sort the valid sequences in order of minimum range to the midpoint. So there was my English input and the C++ that it generated. I would not have been competent to do this in C++. So very, very impressed with its ability to come up with and then some of the things that it writes comments about show that it really understood what I was doing. Like where is it? It's validating the sequences. Sorry for scrolling in front of you here. Okay, if it ended the sequence, it checks if the point K is valid and within the scan range limit. Then it validates the sequence. Here we go. So it notes that in the comment that you can use the actual can radius, which it knows is 0.033 from, because I told it what the can diameter was. So it really understood the can diameter, and it had defined these variables, can diameter min and can diameter max, up front, and then it's saying add a tolerance to the maximum points. It's putting some question marks here for things for me to think about, but it sticks with the formula that I gave it when I told it to use the number of points to calculate the number of points based on the angle increment. So anyway, that's, I think, pretty amazing stuff. So yes. So next thing I thought is worth talking about is okay, I'm in the canfinder account and in the canfinder and in the canfinder package. So let's run slot count on source/canfinder. Okay, so total physical lines of source code are 317. There are actually 525 lines of code when you include blank lines and the and comments. But so physical lines of source code are executable code, or code that will get compiled into an executable. And it says the development effort estimate is 0.7 person months, and gives some complexity metrics. So let's talk about how, what have we really created here? So I had, let's see, in the find cans .md file, I've got 340 lines. So the number of C++ lines that came out of it was actually less than the number of markdown lines that I gave it. Now, bear in mind that some of what I gave it was example code, reference code for example publishers and so forth. But I think it's worth thinking about it's worth asking ourselves and thinking about what have we really accomplished here. We wrote a comparable number of lines of markdown to what we got out in C++, but what we got out in C++ used C++ features that I didn't know how to use. It did a bang-up job of commenting the code. It started over with the code multiple times and didn't complain, which I would not have started over with the code multiple times. I would have tried to, figure out how I could wangle in each new feature or change to the features as I did it. So, all in all, I feel like I came away with a net win because I've done about 5 or 6 sessions, each comprising probably an hour of updating MD, then building it, and a couple of hours of testing to see whether I like it and maybe modifying it a little bit. So let's say, half a dozen sessions of about 4 hours a piece. So I've spent about probably 3 days on getting this 550 line C++ file to where it does a pretty bang up job of finding cans, if I do say so myself.
That sounds like a job to me. I can be at work.
So my goal for this presentation was, first of all, Doug had asked, show us how to get started with Aider. And then second, to show use of Aider in building a real world, reasonably complex application node, and to show in practice the design methodology that I partly got from Bruce Wilson, partly came up with my own way of using Git and starting over from a fresh start. Just to share with you guys, my findings so far. If you want, I can get it to actually regenerate from blank, from no source code and the current MD markdown file. Get it to regenerate from scratch, if you want to see that, or otherwise, I'll just throw it open to comments, questions, whatever.
You
you,
made
Paul.
go ahead. Go ahead.
Yeah,
Doug.
I want to say thank you, Paul. For my needs, you did a great job. Appreciate it.
So, Paul, you made some remarks about vibe coding, and I want to understand if you did anything other than vibe coding in this workflow.
Yeah. So my understanding. So first, let me state my understanding of vibe coding is you give the AI some sort of general vague instructions on what kind of thing it should do. Then maybe you give it a product requirements document, but you certainly don't. I haven't seen that you give it the kind of detailed design spec that I gave it, and then you kick it off and see what it produces. You have a look at it, you try it out, test it, tell it to tweak it, test it again, tell it look at the code, etc. Iterate on that. That's my understanding of vibe coding. Does that match your understanding?
Yes. Well, so except for that very first bit. right? Where you said that it needs to be a vague description of what you want. And so I've seen plenty of examples of vibe coding where people develop pretty in-depth specifications. But I guess the essence of vibe coding that as I understand it is you just accept everything that that it generates for you. And then you test it and you decide if it's broken or not. You tell it to fix it. If it's doing what you want, but you want an enhancement, you tell it to enhance. But the point is that you don't do any coding yourself. And a lot of people don't even read the code that's generated until perhaps, a later review session. So you just march on forward, telling the AI to go as fast as it can. And you're basically just the test and acceptance kind of person up until the point where you decide that you need some new capability, and then you tell it what you want and you just keep on going. So that with the exception of the fact that you iterated on your specification and then told it to start from scratch, how is that necessarily different from just a thorough vibe coding kind of thing? And I'm not advocating vibe coding, by the way. So some of the comments you made out of it about it are, I think, quite useful or quite something to be aware of. But there's also people who are just getting into coding who don't even have the sort of the background to even think about in-depth specification documents, product requirements, and so you could make the argument that this is a way to just get started and start and get some experience and see what happens and learn as you go. So like when it made mistakes, did you stop and start reading the code and try to debug it yourself, or did you tell it to just fix the mistake?
When it made mistakes and things didn't work out right, I read the code. And so an example of that was where I had a can sitting in front of the LIDAR, and it wouldn't see it. But if I moved it a little to the left or a little to the right, it would see it to the left or to the right. And so I figured, oh, okay, it's not meeting the can width parameter because it's not carrying sequences across the cans across the start boundary, the end to start boundary. And so I figured, well, a way to work around that is I'll rotate the scan 180 degrees in the buffer, and then I only really care about stuff that's in front of it, and that stuff will be in the middle of the buffer. So
did you code that, or did you just tell it that this is the next modification you wanted?
Neither. I put it into the markdown and then told it to regenerate from scratch.
Right. So you updated the specification. So you didn't actually edit the code at any point in this process.
I have not edited the code at any point I don't think I've edited the code, any of this code. I might have made one change for test here or there, but then because I wanted it to generate it completely from scratch, Bruce Wilson made a I thought what was a valuable point about automation and automating the generation of this stuff. And the way to do that is to keep the instructions for how to generate it in the markdown file. And then you just push the button and it generates code that works. So as to whether I was doing vibe coding, I didn't know that vibe included detailed specifications up front. So you ask a fair question, and I suspect I suspect there's a range, there's a spectrum with vibe at one extreme and detailed specifications and code reviews at the other extreme. And I'm maybe somewhere in the middle. I don't know.
The way I've taken it is vibe coding is more about the It's not so because the process itself is iterative, right? Because you're always building on something before. So it depends a bit on the tool you're using. It's because you're using Aider, perhaps, that you feel you need, and maybe you just haven't tried it another way, but you're telling it to start over. Whereas in like Cursor or Windsurf, where you're doing it in an interactive environment, what you would do is just it would make those changes into the code base. It would be aware of the changes. If you and in those tools, you would just like automatically accept all changes and just let it go. But you know, the history of the conversation, of the prompt history, is still there. They've got memories, so you can tell it to remember certain parts of the conversation, which is the effect of putting it back into the specification document. And so it's basically just letting the AI agent just go. And it's not about necessarily developing a deep understanding of the code or rewriting it as you go. It's like a lot of people think of like pair programming as the approach that you would take in doing interactive coding with an AI agent, and this is sort of throwing that away and saying just accept everything it does and just tell it when it's done wrong. So that I think it's interesting, and until but one of the reasons that I haven't sort of fiddled with it that much is I can't. It's like my brain just doesn't work that way. If it wants to do something, I'll go look at the code right away, and I'll start. You know, the minute there's a problem, I want to know why it went wrong, that kind of stuff. So it's just, I just don't seem to have the facility for trusting it that much, I guess. So I just haven't been successful. But I think I need to challenge myself to try it further before deciding whether or not, or where it is appropriate and where it is not. I think there are a lot of people who have made good comments about the fact that, you know, you can take it to a certain level of complexity, but it starts having scaling problems once you get to a certain complexity in the project that you're asking it to work on.
So in response to your description of vibe coding and whether I'm doing it or not, if you look at this Git record where it says feet and 3 feet in a row here, that's what Ada puts in, and those are in response to interactively saying, change this, oh, now do this. So that is the vibe coding iterative, tell it to do something new. But where I deviate from going totally that way is I put the recipe back into the markdown file so that I can start over from scratch. So here's another case where...
Well, that's where Aider sort of forces you to do that. Am I wrong about that? I'm not so sure.
No,
like,
no, it doesn't.
Otherwise Aider will just process the, like, it's fully aware of the chat history the entire time, even between sessions.
I don't know about between sessions, but it is fully aware of the chat history, and you can ask it, oh, now change this, now add that. So like here in this latest rev, I told it to, so here's a feature where I started over, but then I told it to calculate poses and bearings relative to the original laser frame, because when I ran it, I saw that the poses didn't line up with the can detections on the LIDAR, and I figured out, oh, it's using the wrong frame, and I looked in the code, and yeah, sure enough, it was using the rotated frame. So I told it to fix it. So you can definitely iterate with it and have it fix stuff in the manner that you described. But then I also put it in the specification so that I can start over from scratch. And I think what I dislike about what you're suggesting, about what you're saying about vibe coding, is if you don't keep a record of what you did, you can't get back to your original place in the same, through the same path.
Isn't that doing that, kind of doing that already for you with the get, commits? Paul, every time you ask it to change, isn't it basically making a comment that's of what you asked? So
Yes, it
in a
is.
sense, that's a
Yes.
little bit of that type of documentation. The question I would from what this little bit that I've played with, not on Ada, but with other coding tools, is that going back to the beginning, even if you think you've specified it all exactly the way you want it to do, it tends to be more problematic than fixing where you are on the current version. You know what I mean? I think the experience that I've found is if you're trying to use this S to help you to learn coding and everything, and it is very good at that, is to use you do small things. For example, you would say, I'll tell you one I'm working on right now for the course. Okay, write a function to drive a motor. Okay, and it's going to be really simple. It's going to be some, simple Arduino sketch. And then you go in and say, well, now I want to add motion control to it. And then it gets more complicated. And then you might want to say, I want to add a PID to it. And it gets more and more and more. But the way I tend to code is I like to have all similar functions in a separate file. Okay, because I do C, I don't do C++. So in that sort of thing, you want to have small bits, and it's helpful if you know something about what you're going to try to ask. You know what I mean? You can't just say, well, give me the best motor control program that you have, because it will try to generate that for you, and it'll have a lot of features. But if it's broke, and it is broke because there's no way you're going to get that, it's going to be broke somewhere, and you're not going to have any idea where it went wrong. So if you start small and then try to add features to it, small features to it, it'll evolve into something that's very useful. And I've also found, instead of asking them to ask them to find them create them as, in my case, functions, that do small tasks, and then incorporate them into a larger sketch that does whatever you want to do. So that seems to be very useful, and very likely that when you get the code that it generates will work if you have the right small steps that you're trying to do. So then you just bring them all together. But it does require some knowledge of what to ask, Anyway, just a few thoughts. So I'm curious. I think the thing that caught me was a little odd was so you're basically updating your specifications and then periodically saying start over. Mm-hmm. And then that's always not worked for me. That's always incorporate, because every time it generates a whole new project, it usually introduces something that either I haven't tested for or is broken. And I found it better to take a single, you might have to do that occasionally, but if you have a project that you started off small and you slowly refine that project, you never have to go back to complete ground zero. Okay. And you shouldn't, the functions that you've added in. Anyway, that's just And I'm, we're all struggling with AI and how to use it.
I found the same thing, Doug, is that you can't guarantee that it's going to regenerate in with the same sort of, because of the history. You can't generate. Yeah, it's just not guaranteed to be come up with the exact same approach. And sometimes it can actually lead to architectural changes that you may or may not have wanted.
Yeah, and sometimes I will say this: I have had things suggest things to me that I had not thought of, and the approach they used would have been not the way I would have done it. I'm not saying it was an invalid approach. I'm just saying it was like, okay, I'm going to learn on this one because I wouldn't have done it that way. You know what I mean? And it's just really cool because you're seeing how somebody put something on the internet that was way different than the way you were going to go do it. And the AI picked it up and presented it to you. But anyway, so I guess that would be my only comment, Paul, was that I don't know about the idea of going back to zero every periodically.
Well, you should recognize that I'm not going back to zero with the specification document, only with the generated code.
Yeah.
And so the generated code should come out according to the specification if I've written the specification reasonably.
Yeah. Yeah.
And it has. I got to say, I've been
You've been happy. Yeah. Okay.
When I tried to get it to do a significant modification to look for sequences that bridged that gap from the end of the LIDAR buffer through to the beginning of the next one, it just was a miserable failure. And I said, start over.
Yeah.
That's an architectural change, right? To rotate the scan in the buffer before you analyze it.
Just for curiosity, because I was kind of thinking about this, and I was saying, well, you really want the 0 point to be pointed exactly backwards.
Yep.
That way, when you're looking forward, everything is continuous.
And that's what I did with the rotate buffer, rotate scan function. It turns it 180 degrees in the buffer, and then it's as if the scan.
Yeah, but I mean, physically on your LIDAR should be pointed backwards.
Yeah, but you don't need to do that. You can just rotate it in the buffer.
Well, I'm going to do a David Anderson on you. If you can fix it in hardware, fix it. So anyway, just the.
I don't think that's an option, Doug, because I'm using ROS for navigation, and it wants to know which direction the LIDAR is facing.
Okay.
But I don't know. Maybe it could be an option if I told it the pose.
I'm just saying, take your LIDAR unit.
Yeah, I understand.
Point 0 backwards.
I'm just not sure that wouldn't break something else in the system.
Okay.
I don't know.
Yeah, you're right. Now, I did see another thing that I was a little curious about. Did you tell it that Y was forward and then X was to the left?
No, X forward, Y to the left.
Okay. All right. Okay. So you're using Ross's standards, as opposed to David Anderson's, and what do they call it? Geological.
Yeah.
Whatever.
Yeah.
Yeah. Okay. Compass. Yeah.
Right.
Okay. Well, that's cool. I really appreciate it. I hope everybody else enjoyed it too. So.
Yeah. Thanks.
Yeah. Well, it's that time again, Paul. It's 9 o'clock.
It's
9:10.
the open mic.
Yeah.
Yeah. Well, I was busy on something that didn't come till later, but today I did, or this week I've been working on my ROS implementation, and I got my sensors and my wheels and everything running good, and then I tried to pull in the navigator piece by piece. That wasn't working well, so I just did the whole navigator thing, and it started navigating.
Well, that's cool.
Excellent.
Yeah, but I tried to get it running after my thing I had to do before this, and when I got in here late, and for some reason it wasn't working right, so no demo. but it was it's still having issues with navigating, but it's actually doing something now. So yeah, the navigator is pretty weird in terms of why it does stuff. I haven't quite figured it out. It should be simple, but yeah, one thing when I first started it was it started spinning real fast, and I realized I reused some code from last year, and I put a 2 pi scale factor on the angular rotation for some reason, and so I took that off, and it started working right. So code reuse is like, oh, why did I put that constant in there? Yeah, it was the wrong place to do it, but last year, but I found it and fixed it. So
yeah, those are always cool, Mike. When you look at last year's software and you find something and you say, how did it even run?
Yeah.
I mean, you know what I mean?
Why did I make that scale factor there? Should have been somewhere
Yeah.
else in the code.
Yeah. That's always cool.
Yeah. So it was. I was working on trying to come up with a way to change the map, like the map that's doing localization to on the fly, and I think I figured that out. So
Wow. Why do you need to change the map?
just different courses and stuff.
Oh, okay.
Like home and DPRG.
Oh,
Yeah. Don't really have to do it on the fly, but there's the sequence coming up. I had to go put it in, and I noticed that when I published the new map, like once a second, the AMCL, the Navigator AMCL, recognized it and does it. And every time it sees a new map, then it makes an alignment to it. So it would shift into the right alignment.
Really?
Yeah.
Wow. So if it gets
must be a better way to do it. I think there's better ways to do it, but I did notice that when it rotated, when it was driving, the map, the LIDAR and the map would get out of adjustment. And so I slowed down the rotation rate in the parameter file, and that helped a lot. Yeah. So
you guys that are going to be using LIDAR this year, you really ought to look at that barrel racing contest. It is just made for LIDAR. You guys could really have some fun with that if you wanted a challenge.
Yeah. Well, Ross is a big enough challenge right now. Once I get all figured out, or if I get used to how to do it, then I'm up to more challenges. But just the code bases, Ross is just so poorly. I hate to say poorly documented. There's a lot of documentation, but it's really hard to dig through. So, It's like, how do you do this? It's like one thing I had is my quality of service on my publisher for my map didn't match the other ones, didn't match the Navigator subscriber. Yeah. And so they wouldn't talk to each other. And so it's like, oh. Well.
How do you change that? I know finding it is just a bear.
Well, I published my own. I mean, there is things in the parameter file to change some of that stuff, but I wanted to not change the what they normally do. I just said, oh, my map generator is not creating the correct quality of service. So, so I figured out how to switch it, how to change it to the other one, doing some Google searches and it's AI code that it would generate and stuff. So it was fun. All right. Well, that's my little update.
Cool. There are a lot of problems to be solved in this 6-can competition, aren't there? Like identifying cans, approaching them, not taking them to a destination, then coming back out, releasing, then coming back out again without them. And I mean, there's just a lot of problems to be solved in this competition.
And the navigator stuff in ROS doesn't do it all.
Right. Yes. That's where I've fallen back on that scripted bot driver code that I'd written for, partly for Robo Columbus, but also before that, just because it was useful. But yeah, Pat had posted in Discord about the rotation rate being a limit for tracking the alignment of the map frame to the ODOM frame.
Yeah, I was looking at that. When you're running a LIDAR and it's doing 5 revolutions per second, it becomes fairly easy to outrun the nav capabilities.
Mm-hmm. Yeah, luckily mine runs at 10, but you still outrun it easy. Yeah.
Yeah, same here. All right, what else have people done or come across that's interesting? Or do we have no robot news today? This week? Maybe we need to call it early.
That's good. Good with me.
Everybody's too busy programming robots, getting ready for the competition in May.
Playing with Ada. Ada and robots.
Going once, going twice, going 3 times. Good night, y'all.
Night.
Yeah.